This video is going to be on set theory. We're going to talk about some basic notation and try and make it a bit more clear for you. So we're going to start off with a Venn diagram. It's always a good way to start when we're talking about sets. So here's what you would sometimes call the universal set, where this is like the set of all things you could possibly talk about. And inside we're going to have three sets. We're going to have one called A. They don't have to be circles, but they're conventionally drawn as circles. With my bad drawing, they're going to look kind of ovular maybe. So here are three sets. It's not too bad. Okay, so this one's A. Oops, that's a bit messy. This one we're going to call A. This one we're going to call B. And this one we're going to call C. Okay, so there are standard things that you can do. There is a union operation. It's called union. And there is this one, which is intersection. Intersection. So you remember them because the union one looks like a U. So this means take both, and this means can't speak. Union means take anything that is in either, and intersection means take only things that are in both. So, for example, I'll try and color coordinate it. If we were interested in A union B, then that would be everything in A. I'll shade the region that I'm talking about. A union B is everything in A or in B. Okay, so it includes the bit in the middle. If instead we wanted, what color should we go with this time? With orange. If instead we wanted, let's say, A, we'll do the intersection of all of them, A intersect B intersect C, then it has to be in A, it has to be in B, and it has to be in C. And it's pretty obvious that that's only this bit in the middle here. So that's the intersection of all of them. And obviously you can have different combinations. So I'll do one more in blue. Maybe a harder one. And sometimes you need to use brackets. So here brackets aren't necessary, but in this example they are. So we can do we can do A. What should we do? A intersect B union C. Okay, in blue. So this means it's either in A intersect B or it's in C. And that or is different to the XOR. So or is, whenever you say or in maths, this means either or both. Whereas XOR, so either or both. Whereas XOR, that's like either but not both. Okay, so for instance, let me think of an example. I just close the quotation marks. So if you had well, we'll come back there. So I've got a little anecdote about XOR and or for a bit, and then we'll get back to the main topic. So if I had the set A is 1, 2, 3, and B is the set, let's say 1 and 2, then if someone asked me for an element in A or B, then like 1, 2, or 3 are all fine. But if someone asks for an element in A XOR B, then only 3 is okay because 1 and 2 are in both, and we exclude that. Okay, so that's a little bit of an anecdote, but that's OR and XOR. So anyway, we're going to do this example. How do we know on our Venn diagram what this corresponds to? So it's in A intersect B or C, or it could be both, right? By this. So if we first do A intersect B, that's this region here. Maybe I'll color it this time so it's a bit more obvious. So this is kind of in between B, C, and this little overlapping bit here. Or it's in C, so it can be in any of C. So it's all of, this is a bit messy, but hopefully you get the idea. So that's in any of this circle, which C is, or in this bit of intersection, okay? So hopefully that makes some sense. Now we're going to talk a bit more about some different notation that you can use. So let's say, suppose now we have sets, and a set is just like a collection of things. We have sets A1, A2, all the way to AN. Okay, so a finite number of sets. It's important. Then we can take their union, like the union of all of these. So A1 union A2 union A3, etc. union AN, and we can rewrite this as the union from I as 1 to n, it's an I, of AI. Okay, hopefully this makes sense. This is like we're indexing all of the sets and we're unioning over all the possible indices. Okay, so this is a comparison. Compare with when you take a sum. So you can take the sum of like AI. These can't be sets here. These are like real numbers. Let's say the sum from I as 1 to n of AI. Okay, this is kind of similar. We're summing over the I, right, where the I go from 1 to n. Okay, so equally, you could write this as the union of the I in some set I of AI. Okay, this sounds confusing when I say it, but we're using a capital for the set and a little letter for the element. This is common. So this is this where I is the set 1, 2, whole numbers to n. Okay, so these are the different ways we can write the same thing, but we can't always. So sometimes you'll see this, and sometimes you'll see this, and at other times you'll see, that looks a bit messy. So sometimes you'll see this, and sometimes you'll see this, but they're not completely interchangeable. So you can always use the second one. You can't always use the top one. The top one only works for finite or countably infinite sets. Okay, so for example, if we had a bunch of sets which were indexed by real numbers, so suppose we have like a 1.1 and a sub pi, a sub 72, etc. But like loads and loads of these, like the same number as there are real numbers. Let's say you have a sub every real number. So I is r in this case. Then you can't take a union like this because there are too many in some sense, right? You have to write it like this. So to take a union of all these, we have to take a union over this, which we call an index set. We're just using it here as an index set because it's the index of each of our sets. Okay, to take the union of all these, we write the union of, you can say alpha, or this could be anything, in I of A sub alpha. Okay, so this just means like A 1.1 union A pi union A 72 union all the other things, all of the other possible real numbers as an index here. So when we say union over a set, it means we have an index set and we're taking the union of sets over every index that lies in the index set. Okay, that's what that means. So hopefully that was all clear. If not, then let me know and I can explain some more, hopefully. Okay.